Hi and welcome to Unit 4 Topic 3 Video 2. Some examples of minimum spanning trees using Prim's and Kruskal's algorithm. Okay, so we have in front of us here a graph. It's a weighted graph and we're going to create the minimum spanning tree using, first of all, Prim's algorithm. And I'm going to have a list that indicates the process to follow with Prim's algorithm coming up here now. Okay, so if you want to write that down you could pause the video, but otherwise it should be any other resources you have. Now, let's follow Prim's algorithm. The first thing we do is just arbitrarily pick one of the vertices. I'm going to pick A because it's just there. So we start with A, and then I connect A to whichever other vertex has the lowest value connection. So I'm going to connect it straight up to D. There's D, and A and D are connected like that. Now, that's 5. Next thing I'm going to do is I'm going to look at A and D and pick the next lowest value. So I've used 5. I've got 6 available from D and I've got a 6 available from A. So I think what I might do is I might follow from A again and go across to B. It actually doesn't matter which one I choose. Okay. So now I've got A, B and D in my system. I just need to connect E and C. So I'm looking for the next lowest available one. And this actually brings this 4 in line. So I've used that one now. 4 has now appeared as an option. And it's the lowest on the whole system. So I'm going to use that 4 to get across to C. And now I just need to connect E. And I need to find the lowest one available to connect E to one of the existing ones. And I can see it's going to be this 6 here. So E, which is down here, is going to be connected that way. And the weight, the total weight of this network is now 6 plus 6 plus 4 plus 5, which is 21. So there it is, 21 using Prim's algorithm. Of course, we could have had this connection and not had that connection for the same result. So there's multiple answers here. That's Prim's algorithm. I'm going to swap it now, and I'm going to bring up Kruskal's algorithm. Okay, so in Kruskal's algorithm, we're looking for the edge with the least value. So I'm going to start by putting that in because it's already there. We've been using it already. It's B to C. And now B and C are in our system, and that's created an edge. It hasn't created a loop or multiple edges or a cycle. So I'm happy to leave it at that. And of course, I don't have to look at multiple edges because that would create a cycle. Now I'm going to go to the next lowest, which is A to D, the 5. So there's A, and there's D. Okay, now I'm going to go to my next lowest, but I've got options. So 6, 6 or 6. So I'm just going to pick this top 6. A to B, doesn't create a cycle or anything. So there we go, 6. I'm going to pick the next 6, E to B. That doesn't create a cycle or anything. 6. And look at the next 6, that would create a cycle. And in fact, if I have a close look now, I can see I've finished my network. And it's exactly the same as that one there. But again, had I have looked at the 6s in reverse, I would have left out the AB edge and put in the DC edge and it still worked. So there is Prim's algorithm and Kruskal's algorithm on this simple case. I'm going to rub all this off now. We'll do one more complicated case and we'll leave it at that. Okay, so here's our second example and you can see the graph there. It's a weighted graph again, but it's a little bit more complex. Not that much more, but it's a little bit more complex. It's worth doing a bit of analysis at the start. 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. So my minimum spanning tree should have 8 edges. So always good to remember that. 8 edges. And I'm seeing some 1s and 2s probably going to be in there, but we'll see how we go. So we're going to start with Prim's algorithm. We'll do it here, and I'll arbitrarily choose A. So from A to B is 4, that's my best. So I'm going to go to B, and that's 4. And in fact, I think what I'm going to do is I might add all the vertices now, just so it's all done. E, F, G, H, and I. Okay, and then we can move on from there. So I've connected A to B. Now I've got anything from A and B. So I've got an 8 from B, I've got an 11 from B, I've got an 8 from A. So it doesn't really matter which one I choose. So I might just choose this A to H. That's an 8. That brings in H. 8, 11, 7 or 1, so we've got to bring in this 1 because that's my lowest value there. And now I've incorporated G, and I can see a 2 has appeared. I've got a 6 and a 7 available, but I've got a 2, so I'm going to use that 2 to get to F. Now F has become available, and from F I've got a 4, and I've got nothing better than a 4, so I'm going to use that 4 to get to here. And now C is open, so I'm looking around at C and I can see a 2 down to I, so that's good. I just need to get to D and E. So, looking at what I've got available now, I've got a 6 available, but that creates a cycle. I've got a 7 available, that creates a cycle. I've got this 7 available, that's next best, and that incorporates D. So it gets to a point now where I can see the few I've got left. I can kind of work backwards. I need to get to E, and it's a 9 or a 10 option. I'm going to choose a 9 option. And there it is. So, that's our minimum spanning tree, and I use good old Prim's algorithm. And now let's do good old Kruskals and show that we get the same answer or an equivalent answer. Because of course the weight is the most important thing. The weight should be the same. 4, 12, 13, 14, 15, 19, 21, 28, 37. So I should have a weight of 37. Okay, Kruskal's algorithm says start with the 1. And in fact, what I might do is I might again draw ahead, which you don't have to do, and sometimes it's better not to because you don't actually miss things. But I'll do it for the sake of this video and time. C, D, E, F, G, H, I. Okay, so we're going to go to the smallest, that's the 1. And that's all good, doesn't create a cycle. I'm going to incorporate the next smallest, which is this 2. Doesn't create a cycle. I've also got another 2 up here. Doesn't create a cycle or a loop or anything like that. Okay, what have I got now? I've got some 4s available to me, and I can use all of them. So there's a 4 there, and there's a 4 here. None of those create loops or cycles. Okay, cool. I've got a 6 available to me, but that creates a cycle. So I'm not going to use that 6. You're out, mate. Sorry about that. I've got a 7. That creates a cycle though, so you're out, mate. Sorry about that. I should actually just tick the ones that I have used. Now I've got a 7 here. So I'm going to incorporate that 7 because that doesn't create a loop or a cycle. And so I've used all the 7s and stuff now. I'm looking at the 8s. I've got an 8 here. That's okay. That's not going to create a loop or a cycle. And now I'm looking for my no more 8s. I've got an 8 up here. But I'm not going to use that 8 because that would create a loop or cycle. But note here, I could have used that 8. That would have been fine, just not use this 8. That would have actually worked. So there's alternate solutions here. And I can't rub this pen off very well. Okay, 8's out. Now I'm going to go to my 9s. 9's here. I can use that 9. And I get everything connected. So I can stop. And that is my minimum spanning tree. Thanks to good old Kruskal's algorithm. Now, Prim's algorithm is mentioned in the syllabus. Kruskal's not so much, but it's a mention as in using techniques such as Prim's algorithm. So realistically, you should be able to use either. But this one could be called on. That's the key. So it's probably worth definitely knowing Prim's algorithm, and if you know Kruskal's as well, then you get to make the choice in most cases. Thanks. Well, thanks for joining me on these 2 videos regarding minimum spanning trees. All the best.